Now we also have other types of functions. For example, well, what if we looked at the constant function 2? So in other words, if you thought about y equals 2, well, what would that look like? Well, that would be a horizontal line because it has a 0 slope and y is always equal to 2. So in this particular problem, you might say, well, what is the order of this guy? Well, our independent variable, our input variable, is not present. So in reality, here's what I could do. I could say that this is really 2 x to the 0 power. So we know that any non-zero number raised to the 0 power is equal to 1. So that means that 2 times x to the 0 is the same thing as 2. And therefore, this would be order 0. Now, even if those terms are arranged, so if you rearrange, so if you had x plus 2x squared plus 3x plus 3, that's still order 2 because its variable with the highest exponent value is the value of 2. And now, so that leads us to an important idea which deals with those horizontal asymptotes. So before we were just kind of finding out what happened as we continued to increase our input value away or towards a vertical asymptote. So we kind of just observed, like if this was an asymptote, we just wanted to see what was happening as we got closer to it. Was it doing that, or was it doing this? And similarly, going away from it, what was happening? Was it getting closer to 0, or was it getting closer to positive 5? We don't know exactly what or why it was happening that way. Well, here's a theorem that basically says that your horizontal asymptotes depend on the order of the numerator and denominator. So if the order, and this just reads like it would in words, if the order of your numerator is equal to the order of your denominator, then the horizontal asymptote is the ratio of coefficients for the highest ordered terms, numerator divided by denominator. So let's look at an example of this. So first of all, like if we had 2x plus 1 over 3x plus 2, well, in this case, the order is 1 on top, and the order is 1 on the bottom. Therefore, this says that the coefficients of those variables, of those the variables that represent the order, the ratio of those guys, numerator divided by denominator, would give me my horizontal asymptote. So in this case, it would be y equals 2/3. And I think we saw that in the previous video too. We just kind of noticed that it happened to be the ratio of these two numbers. Well, let's look at this more closely in the calculator. So here we have entered in already 2x plus 1 divided by 3x plus 2. An extra symbol there. And so what I'm going to do is just go to second window to set up my table. And I want to start at 0. And I'm going to maybe change my table by increments of 100 just so I can see what's happening. So I'm going to go to second graph. And here's what happens. It looks like as we get bigger into the hundreds, we are seemingly getting something closer to just a bunch of a decimal and then a bunch of sixes after the decimal. Well, guess what? 2 divided by 3 is about 0.66666 repeating. And so that's why we're seeing that, the ratio of these two values. Now, you might wonder, well, okay, why is that the case? Well, it has to do with the fact that the numerator is increasing equally as quickly as the denominator. So this one's increasing by, excuse me, not equally, but proportionally. So for every increase of x by 1, the numerator increases by 2. For every increase of x by 1, the denominator increases by 3. The only thing keeping this from looking like 2/3 is the fact that you're adding that to 1 and you're adding this to 2. Eventually, once these terms become individually very, very large, the plus 1 and the plus 2 don't really have much of an effect on the numerator or the denominator. And so we notice that this thing keeps getting closer and closer to 2/3, because of course you know that 1 divided by 2 is 1/2, but 101 divided by 102 is almost equal to 1. The ratio is almost the same. These two numbers don't make much of a difference. So what would this graph look like? Well, we know that if we began to sketch it, y equals 2/3, so if that's y equals 1, I would have an asymptote running horizontally this way. Remember, that's the line that our function approaches but never crosses. And what would my, so this is my